Okay, so the first thing, whenever you approach a question like this, remember that you can start from the angles, you can start from the sides, you can start from any part you want. All right, so if you start from, let's say, the angles, you have the adjacent side or the opposite side, and you also have the hypotenuse. So maybe we can start from maybe labeling each of the sides. Okay, so I'm going to label this height, and I'm going to label this A, DJ, which is adjacent, and I'm going to label this opposite. All right, so from that, I can see the quickest way to find x would be Pythagoras theorem. So I know that x squared plus 54 squared is equal to 43 squared. And that's Pythagoras theorem, right? So just a quick recap on what Pythagoras theorem is that if you have a right angle triangle, you've got A, B, and C, then A squared plus B squared will equal C squared. And that's basically what we did over here, where this is A, and this is B, and this is C. And so we then substitute that into here for ABC, and from that we solve for x now. Right. So this is going to become x squared is equal to 43 squared minus 54 squared. How did I get that? I'm just subtracting 54 squared on both sides to cancel it out, isolating x. Let's see what x squared will become when you put it on a calculator. So what you'll notice about this will end up as negative 1067. Okay, so the biggest problem with this question is that the hypotenuse is supposed to be longer than the adjacent. All right, which means that this is no solution, completely no solution for this question. All right, and how can we see this? We can see that Pythagoras theorem does not hold, right? And if Pythagoras theorem does not hold, that means we can't even start the question. We can't even find angle alpha and theta. Whenever you have a right angle triangle, remember the following, that the longest side is always opposite the 90 degrees. And generally, when you want to prove Pythagoras theorem, you've got to substitute in here and see if you can get to that side. But in this particular case, this has to be the longest side. And then this is your adjacent, etc. So this question would be no solution. All right. If you're given three sides at any point in time and you want to prove Pythagoras theorem, remember that you have to prove a squared is equal to b squared. So let's say I got 3 over here, and I got 5 over here, and I got 7. And the question says prove that it's a right angle triangle. Prove it's a right angle triangle. All right. So in order to do that, I can take 3 squared plus 5 squared equals to 7 squared and prove that Pythagoras theorem will work. And this will be 9 plus 25 equals to 49. And you can see that's going to get me 34. That's not equal to 49. So no, it's not a right angle. Okay, which means that angle there is wrong. All right, this triangle is false. If these two are equal on both sides, then Pythagoras theorem holds. All right. That means we can then say the triangle is that. Okay, so this question here, if you picked it up, it was the fact that this length over here was shorter than the others. Now, based on this, let's see if we can go through another question and try and find or try and solve the triangle completely. All right.